In this video, I want to talk about one of the catabolic fates of pyruvate, specifically fermentation. So once pyruvate is made, it can go to, what happens to it? It can go to a variety of places. If there is oxygen available, then pyruvate goes to the TCA cycle, which is also known as the Krebs cycle, which is also known as the citric acid cycle. And then after that, it would go to the electron transport chain. Well, eventually it would go to the electron transport chain in another form, in the form of NADHs and FADH2s, which can be reoxidized and make lots of ATP. More on that, the details of all that sort of stuff later. But if there's no oxygen available, that's when we have this thing called fermentation occur. Now, I'll talk about the purpose of fermentation in just a moment. Before I go do that, there are two types of fermentation. There's lactate fermentation, which happens in animals, and there's alcohol fermentation, which occurs in yeast. So let's talk about those. So now, lactate fermentation, we start off with pyruvate, right, because this is the catabolic fates of pyruvate. In animals, and including humans, right, we have pyruvate. What can happen is it can be turned into lactate, which is the conjugate base of lactic acid, which many of you may have heard about in terms of stuff that builds up in your muscles when you get sore. So the enzyme that catalyzes this step is called lactate dehydrogenase. There we go with that dehydrogenase word again. So we're going to think redox reaction, and we're going to pay attention to what happened here to the what happened to this molecule. What happened to pyruvate? The carboxyl group stayed the same. Nothing happened there. The methyl group also stayed the same. The difference is here that this carbonyl group was turned into an alcohol. And this actually is the example that I used previously in another video as an example for oxidation reduction. So this here has two bonds to oxygen. Here it only has one bond to oxygen, and it also had gained hydrogens. Both of those things mean this pyruvate was reduced to lactate. So if pyruvate was reduced, something must have been oxidized. Well, that's why we think about the dehydrogenase. In this case, what's happening is we're having an NADH get oxidized back to NAD+. Now, why do we do that? Why is it that we do that? The reason why is because now this NAD+, this NAD+, can go back and be used in glycolysis to make more ATP anaerobically, right? Because because there's no oxygen, right? We need to make this ATP anaerobically. Now, the reason why we need to regenerate NAD+, this is actually the purpose of fermentation. The purpose of fermentation is to regenerate NAD+. Because NAD+ is a physical requirement of glycolysis. What does that mean? What does that mean to be a physical requirement of glycolysis? Well, if there's no oxygen available, that means the only way that we can create energy is through glycolysis. So in glycolysis, if you recall, what ends up happening is that each time we go through glycolysis, we net 2 ATP. In that process, we use up an NAD+ and we make an NADH. So basically, if you continually have glycolysis running, you'll take all of your NAD+ and turn them into NADHs. So you can't have glycolysis keep going if you don't have NAD+. You need NAD+. NAD+ is a physical requirement of glycolysis. So what happens with fermentation is it takes those NADHs that you made in glycolysis and reoxidizes them back into NAD+, so that you can keep going through glycolysis. Okay? So the purpose of fermentation is to regenerate the NAD+. That way glycolysis can keep going and keep giving you energy anaerobically. One thing I'd like to know as just a sort of fun fact is that the reason this happens in your muscles when you exercise anaerobically, lactic acid builds up in your muscles, and that that pH change, that lowered pH, is what causes muscle soreness. At least that's what I've heard, and I think that is the case. Anyway, let's move on to alcoholic fermentation. So in yeast, things it actually happens in two steps, and it's a little bit different. So we start off with pyruvate, and we turn it into acetaldehyde. Okay, and so what goes on here? This methyl group stays the same. This carbonyl group, we still have a carbonyl group here. Here is an aldehyde. Here was a ketone. But basically, we lost this carboxyl group. This was a 3-carbon molecule. Now we have a 2-carbon molecule. So we lost this carboxyl group here. The enzyme that catalyzes this step is called pyruvate decarboxylase. Okay, we lose that carboxyl group. How did we lose it? Well, the way we lost it was as a carbon dioxide, or the way it was lost. So when yeast undergo alcoholic fermentation, CO2 comes out. Okay, this process here is how beer is made. So once we have this acetaldehyde, we have this aldehyde group here, this 2-carbon aldehyde group. We're going to turn it into ethanol. So what's the difference here? We still have this methyl group and this methyl group here, except we turn this aldehyde into an alcohol. So here we had 2 bonds to oxygen. Here we have 1 bond to oxygen. So acetaldehyde was reduced, right? So if it was reduced, something else was oxidized, and of course, in this case, the purpose of fermentation, of course, is to regenerate that NAD+. So we oxidized NADH into NAD+, and the enzyme that catalyzes this reaction is alcohol dehydrogenase. Alright, and so that's basically it. Notice that in both of these cases, we regenerated NAD+ so that it can go back through glycolysis, again, because it's a physical requirement. NAD+ is a physical requirement of glycolysis. Glycolysis cannot continue if it doesn't have a supply of NAD+. Okay, so that's the purpose of fermentation. It allows you to regenerate this stuff so that you can keep going through glycolysis and keep making energy anaerobically. Hope that was helpful. Thanks for watching.